Hello everyone. In this lecture we are going to learn about API 579-1 ASME FFS-1 Fitness for Service. Our flagship courses are Master Static Equipment Design and PVE Light, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs. So do visit our learning platform for more details on scutoid.thinkific.com.
API 579, we also call it as ASME FFS-1. Both are same code. Okay. In 2007, API 579 was merged with ASME, and after that we call it as ASME FFS-1 or 579. Okay. So anything you can call, it all means same thing. What do you think will be the definition of fitness for service? What exactly the purpose of this code? The name itself might be indicating something. As the name suggests, fitness for service. Whether my equipment is fit for service or not, right? So if I give you the definition, a very simple definition of it. Okay. To check the equipment if it's fit for continuous service. Okay. Most of you responded in the same manner. So typically, whatever is my next shutdown, till that time, whether that equipment can be operated or not. Okay. So I'll be always doing the fitness till the next shutdown. Okay. To get estimate that whether it can run, or do in the next shutdown, I have to replace. Okay. So I have to be ready with that equipment. Whatever I have to do, if any repair is required, and after repair, if I can certify it for use, that's good. Otherwise, for replacement, I have to be ready. I need time for that, right? I cannot immediately replace equipment. So what exactly we check for fitness for service? We check for flaws, whether there is a flaw. Okay. Now, what kind of flaws may be there on the equipment? Like if I'm doing fitness for service assessment, my first activity will be doing the inspection. Okay. So what are the things which might be looking for? Cracks, pit holes, corrosion, right? The corrosion, we can estimate what is the thickness which is remaining. And with that, we can estimate what is the rate of corrosion which is happening. Okay. The corrosion is local in nature. To some reason, it has corroded a lot, or it is uniform. Okay. So it's general metal loss or local metal loss. Okay. So assessment for both are different. Yeah. So thickness checking, lamination, dents, crack, creep damage, fatigue. So if there are any cracks, so we have to evaluate for fatigue. The crack, also we have to evaluate. Entity testing. Yeah. So entity testing is the means by which we'll be investigating all that, right? If crack is there or not, we'll be able to estimate only by doing ND. Right? Brittle fracture. So during the shutdown, we'll be doing the inspection of that equipment to check for all of these flaws. Okay. And we'll see what exactly, if there is a flaw which may be damaging the life of that equipment. So we have to assess with that damage, how long I can operate that vessel. Okay. So that is what we do in fitness for service. Okay. Then we have, you may have that equipment made with very old standard. Okay. Now the standards are changed. Okay. So with changed standard, whether I can continue to operate, whether that design is still acceptable as per my latest code. So that also may be evaluated. Next. See, this fitness for service is not work of a single department. It's not only inspection or quality is involved. How many departments are involved? Quality, obviously. What else? Inspection, vessel design engineer, because the data will be given to vessel design engineer to estimate. Metallurgist, okay, or material engineer. Very important, because seeing the nature of corrosion which type of corrosion has happened. Okay. He will be able to estimate that whatever was thought in the start, whether it is in line or something different is happening. So based on that, further operation of that equipment can be decided, right? Yeah, maintenance process also may be involved. So whatever design conditions are there, okay, and if I see that if there are some damages and with the current parameter, if I'm not able to run, can I lower the parameters? Even it can be otherwise. If my equipment is based on whatever estimation was done earlier, if the corrosion has not happened, can I run it at higher pressure and temperature? That also may happen, right? How aggressively I can go. So you have to involve process piping engineers, right, in evaluating the stresses in pipe. Very good. Okay. So almost every department we have covered. So it's a multidisciplinary activity. Okay. So like stress analysis. No, not all the time you'll be doing stress analysis. You have 3 level of assessment in API 579: level 1, level 2, and level 3. Level 1 and level 2 can be done just by design by rule. You don't need any software for that. Level 2, if the software is there, it will definitely help, but you can do it manually also. But level 3 is like either for piping, you'll be using Caesar, or for equipment, you'll be using ANSYS or any other FEA softwares. So stress analysis may have to be performed, or design by rule has to be done. So that will involve your design discipline. Okay. Then material science or metallurgist. Yeah, CFD also may be required. If some flaw is changing your nature of the flow, right? And some location you might see the damage is very high. So you want to understand the flow. So you can do CFD also. Okay. So material science and metallurgist, very important role. Why? Because based on the data which is generated by that inspection, they will see what may be the impact in the further lifetime of that equipment, whether it can sustain, it is in line with the earlier thought, like if this material is suitable or not for that service. Okay. See, if you think about 579, it is mainly based on the data. Okay. The assessment which we are doing, we are generating data and we refer the old data. Okay. Like material science or metallurgist, they use lots of software to predict the corrosion allowance or whatever damage may be there in that process environment to the metallurgy of that equipment, right? So lots of software, like if you name few, ECE is one of the software. Then you have DNV, okay, DNV GL's corrosion manager, and we also have CAPS. So there are some softwares which predict the corrosion rate, okay, over the behavior of material in that particular service. Okay. So that's very important. We have to involve material science or metallurgist in that service or in the FFS when we are doing it. Okay. So ND, definitely very, very important. So ND is the, if you talk about 70% or 80% area in FFS, that is covered by the ND. Everything which you are going to do, that will based on ND, what you are doing on that equipment. So that will generate the data, and based on that, you'll making the decision. Okay. Next, you have definitely corrosion. Based on ND, you'll get the data of corrosion, and then you'll come to know that whether it's in line or the rate of corrosion is more than what was expected. So either you'll reduce or increase the remaining life of that equipment. Plant operation, whether you want to further use at the current design pressure and temperature, you want to reduce it, or you want to increase. Okay. Every decision will be made based on whatever data we have generated and after doing the fitness for service for that equipment. Okay. Now, do we have cost benefit also after doing fitness for service? What do you think? Do we have cost benefit also? How cost is coming into play? So cost is very much involved in this. Okay. So if by doing the assessment, you can continue the operation of that equipment, so it will help you to replace. You don't have to replace that equipment. Okay. So unplanned shutdown. So you can avoid unplanned and the most of all, the failure of equipment. If the equipment fails, you can imagine the cost which will be imposed. So not only terms of money, but also the hazards that will happen. Okay. You may even, there may be loss of life also. Okay. So definitely there is a cost benefit. So doing FFS compared to the cost of failure is almost negligible. Okay. In FFS, we are doing only design and inspection work, okay, which is very less cost. If the equipment fails, if you have unplanned shutdown, you can imagine the cost which will be lost. Okay. So it's very important. And nowadays, the uses of FFS has gone much higher. Okay. Most of the plant and the equipment which are there in plant has seen 25 years of age. Normally we design for 20 to 25 years, right? So many of the plants are like that. So if I give in terms of percentage, almost 40% of the current equipment or plant, more than 40% are more than 25 years. So all that will be coming for inspection. So in current days, you will be also noticing most of the companies are adding this additional branch. Okay. Revamping unit, re-rating. The department will be doing re-rating of the vessel. They will be involved in the maintenance. Okay. So that is going to be a very big business, and definitely it will generate lots of employment. So it is going to definitely increase, and it is increasing. The number says that. Okay. I'll be sharing that in a meantime with you. Okay. If I don't do FFS, what will happen? You may see failures, isn't it? So this is one example of, this is a very old plant, and it was ammonia plant. And there was a vessel. This is a bottom descent. It's a inverted image basically. It's a bottom descent connected with a strainer kind of internal equipment. So this equipment failed because of brittle failure. What was the reason for that? It's a very old, almost 100 years old failure, which I'm showing here. So that time even fitness for service didn't exist. Okay, it's very new. 1990 it started. Okay, so that time, ammonia cracking. So that time this concept was not there. So people were not doing fitness for service. Okay, so you're not able to estimate or not doing even inspection to see what are the damages which are there on the equipment. Okay, and that damage will keep on propagating, and after some time it will fail. Okay. If I do fitness for service, I will be able to estimate. I'll be able to come to know that this may be the reason. Okay, if not 100%, at least 70-80%, we will be able to predict that this may be the reason for future failures. Do you agree with that? that if we do assessment, if we do proper inspection, okay, and do the analysis, we can prevent multiple failures. Okay, and you can understand what will be the impact on the plant. Okay, not only in the terms of cost, but also the lives which are lost. So any failure is very, very catastrophic and very much dangerous. Okay, and it takes all the technology years behind. Okay, so in this case, what was the reason? The main reason was, see, that material, that bottom descent was casting. Okay. Casting is, you can see the thickness. Okay, it looks to be more than 4 inch. Okay, so it was casting. Earlier, that uh, arrangement which is there of strainer kind of arrangement, uh, it was not welded to that bottom descent. Okay. Welding was not done. It was just kept on the bottom descent. So it was vibrating, creating noises. So someone thought, why not to weld it? Okay. So when the shutdown happened, they welded the strainer to that bottom descent. And post weld treatment was not done. Considering it's a small weld and it's not a pressure part, so how does it matter? Okay. And because of that, it's casting. Casting has little bit higher carbon percentage. Okay, so they are prone to crack more than your normal pressure vessel material. Okay. Carbon steel plate, if I take. So there was a small crack which found, and what was the reason for the crack? So the strainer and that bottom descent both will have different thermal expansion during the operation. Okay, so there was residual stress because of the welding, additional stress getting created during operation because of the differential thermal expansion. It's a circular weld, right? So it will try to restrict while the descent is quite high thickness. Okay. So small crack generated, and that led to the catastrophic failure of this complete equipment. Okay. So if the assessment would have been done, it would have been noticed prior to that failure. Okay. So the lesson was learned after seeing many failures. It was felt that if we can do the fitness for service, definitely we can avoid lots of failure like this, which is happening in the plant. And definitely the committee, as usual, were formed by the companies. Okay, there is no other committee which is looking after these things, right? These things are identified, the bigger companies, they form a group or committee, and then finally gets merged to the standard. Okay, so in 1990, early 1990, that committee was formed, which was having lots of bigger companies. People got together and started creating some rules. Then API. So basically, they started with the refinery and oil and gas, right? The starting point was that. So big companies in oil and gas, they came together, formed this group. Then API, because many of them were member of API. So once a good set of rules were created at the end of 1990, there was API FFS committee, which was formed. In 2000, they published the first FFS standard. In 2007, it was merged with ASME and it became API 579 ASME FFS-1 standard. Okay. In 2007, you can see how recent. 2016, it was revised. Again, revised in 2021, which is the current version of API 579, which you are using. Now you may be able to see that the improvement or the revision in the standard is not very frequent. Do you notice that? From 2007, it took how many years? 9 years to revise that standard. Is it a good amount of time or not? Yeah, very long time to revise a standard. Okay. Now, why these things happen? Because there was no special group and the funding was not there for this particular group. Okay. Still, that is happening because everybody who is part of this committee, it's not their full-time job. Okay. And nobody is working full-time for this. Everybody who is part of this committee is working full-time somewhere else. It's their part-time job. Okay. And that is the reason it is taking more time to create, and the more data we have, it will become more strong. So even if you see 517-1 now, in terms of carbon steel and low alloy steel, we have lots of data because majority of the vessels are using that in oil and gas and refinery industry from where it started. So for pharma or the newer metals like titanium, which is getting used now, we have very less data for that. But if you think about carbon steel and low alloy steel, we have lots of data. So now we learned the background of 579. Now, what is the scope? And scope is related to which kind of industry. So now it includes, started with petroleum, but now it includes power, pipeline of even different industry. Pipeline of petroleum definitely included in petroleum. And then chemical and petrochemical, okay, pharmaceutical. Now aerospace also, it's there. It is used in aerospace also. But the data for these newer industries like pharmaceutical and aerospace is very less. So it's very, very relevant to petroleum industry. Compared to that, less relevant to petrochemical or even pharmaceutical and aerospace. It deals with many, many different codes. It's not only for ASME, but ASME pressure vessel code, all the different sections, section 1, section 3, section 8, division 1, 2. Okay. You also have ASME B31.1, which we used for piping, 31.3 for process piping, 31.4, 31.8. All these codes are included in 579. Okay. These are the mother code. By using that equipment is designed. The programs has to be different for different codes, right? So few software may include a little bit more code. Like if you think about PV light, it includes section 8 division 1 and also division 2. But piping code is not included. So for that, you may need different software. API 650, 620, 530, all these different codes. Okay, and not only this, but other codes are also included in this codes and standards. So lots of standards are referred. That is the mother code for designing of that particular equipment. Once we are doing fitness for service, 579 is also having lots of rules. Okay. If it is related to section 8 division 1, you'll see different rule. If it's related to piping, B31.1, we having different rules. Okay. So it matches the fitness for service and the mother code. So it connects them. Now let us see what are the different things which are covered. The table of content. What exactly is there in 579? So part 1 covers normal introduction, which we are talking about right now. Part 2 deals with general assessment procedure. So that is referred by all the different parts. Okay. It's like UG of section 8 division 1. Okay. So it covers lots of design by rule formulas, assessment procedures that is referred by the different parts. Okay. So part 2 is very, very important, but not specific to any particular flaw or crack. After that, whatever parts you'll see, that is related to a particular crack or flaw, fatigue, creep. Okay. So starting with the part 3, it is related to brittle fracture. Okay. So brittle fracture, the one which we saw in example. So that is one example of the brittle fracture. Okay. Yeah, Suresh is saying, what are the different levels? We'll talk about that, Suresh. So there are three different levels which are there. Level 1, most conservative. Level 2, okay, once we go to level 1 to level 3, it becomes less and less conservative. That means the design becomes more and more accurate. Okay. So more conservative means more design factor. Okay. More safety factor. Make sense? So if your equipment is getting clear with the level 1 assessment, if it is getting qualified with level 1 assessment, you don't have to go for level 2. If I'm not able to qualify with level 1, I can do level 2. Even level 2 is not getting qualified, I can go to level 3 and qualify. Okay. So the flow will be like that. Hope it makes sense to all of you. Okay. Part 3 is related to brittle fracture, which we saw. The procedure, if you refer, it's very similar to what we do for UCS 66 and 66.1. Okay. Calculating the MDMT values and doing the stress ratio calculation 66.1 for reduction. So it's very similar, part 3. Part 4 is the metal loss, general metal loss. If due to corrosion, you have seen loss of material almost everywhere, it's not related to a particular location, it's a general metal loss, then you'll be doing part 4. If you find a local metal loss, okay, in local area, the material loss is very high, then we have to apply assessment part 5, which is local metal loss. You have part 6 for pitting corrosion. So if you observe that there is a pitting which has happened after doing the ND, then you'll be doing the assessment with part 6. Part 7, if it is related to hydrogen blisters and hydrogen related damages. Okay, that is part 7. Part 8 is due to weld misalignment and shell distortion. Okay. So due to quality of the shell, the weld is getting misaligned. Because of that also, you may see problems later on. So that is assessed by part 8. That may even happen at the new stage. You have done the welding, there is a misalignment, or OLT has exceeded the value which was acceptable. Then we do assessment to see whether I can operate at the same duration or I have to reduce the life because of that. If I don't want to straight away throw that vessel, okay, definitely will not like to do that. So we do assessment and try to utilize that. If you have find cracks, crack-like flaws, then part 9 will be using for the assessment. And it's not like only one part you may be using. You might be using multiple parts altogether. Okay, we'll see that also depending upon the type of damage. You may be referring or analyzing with multiple parts at the same time. Part 10, which is related to assessment of components operating in creep range. Part 11, assessment of fire damage. That very rarely happens. Part 12, assessment of dent. Okay, this may happen because of any operation which is happening on the plant, and it gave a dent to your actual or running equipment. So dent, causes, or combination, you can analyze it with part 12. Part 13, assessment of lamination. Lamination is also a similar kind of similar to cracks, but it is not on the surface. Okay, generally it happens during the material formation. Like when the plate is getting formed, that time you may have lamination. Okay, now that may increase during the operation. So when you're doing ND, you will see the length and the width of that crack, and you'll be, if you can define it as a crack, then it will go with the different part. If it is lamination, so there are limitation given, like what is the length of that and what is the orientation of that crack. Okay, so then you can define it as lamination or crack, and doing the assessment based on that part. Okay. Then you have part 14, the last part, which deals with fatigue damage. Okay. Now, this is not the end. Okay. API 579 is very recent code, and there are a lot many parts which are going to be added. So lots of work is going on for addition of multiple parts. So I can give you few of them. These are still not included. Okay. But and part also may not be the same what I'm showing, but just for the sake of what is going on, we can see the piping vibration analysis. Okay. So what if you noticed some pipe is vibrating a lot during operation, you can assess that what may be the life of that. Okay. When you need to replace, if you're not able to control that. Okay. HTHA, okay, high temperature hydrogen attack. Okay. So in recent times, uses of hydrogen has gone very high. And that is the reason we are referring division 2 code. So HTHA is getting developed for high temperature hydrogen attack application. Then you also have part 17, hotspot. Okay. Local areas, if you're seeing very high temperature because of the flow of that fluid, you may consider using part 17, which will be upcoming parts. So maybe next revision they may be included, may not be included. So still work is going on that. So these are the parts which are there, may be coming in future. Now, this is very important. Okay. So based on the assessment, when we are doing during the fitness for service, we are doing the NDE examinations. So you'll see what is the damage mechanism, and based on that, your assessment procedure will follow. Okay. Now let us see this figure. Okay. If the damage mechanism is brittle fracture, then you'll be analyzing with part 3 as well as part 9. Okay. You may have brittle fracture, or if a small crack is there, okay, which may lead to brittle fracture, that you'll be assessing with part 9. Okay. If you have corrosion or erosion related issues, which may be very common. Okay. This is the most common type of damage mechanism. It always present. Okay. So you will be assessing with part 4, which is general metal loss. You will be also assessing with part 5, which is local metal loss, if you find something locally. Part 6 for pitting. Part 7 for blisters. Okay. If you have crack-like flaws, mostly you'll be doing with part 9. Don't need any other damage mechanism or damage procedure. If it's a fire damage, then you'll be doing with part 11, which is for fire damage, part 4, part 5, part 8, part 9, and part 10. So almost, you are going with 6 of different assessment for that. Creep, as a separate procedure is there for that. Mechanical damage includes part 5, part 8, part 9, part 12, part 13. And then you have fatigue, which refers part 14. Okay. So depending upon the damage, you will be assessing with the relevant procedures, and covered in different parts. Okay. So you may be utilizing multiple parts to assess your equipment. Okay. Great. So this is briefly what exactly your 579 is. So you saw there are total 14 parts which are included, and every part is assessing some or the other flaws. Okay. So most of the time you may be referring a particular part, but you need awareness of all the different parts. Okay. And all the parts have 3 different assessment procedures, 3 level of assessment. Level 1 assessment, where it's most conservative and design by rule is much simpler. Okay. You can consider it as division 1. Okay. Then you have level 2 assessment, which you can consider as division 2 part 4, little bit more evolved equations, more trickier one, difficult to use just an Excel sheet or doing by hand calculation. You may need some of or the other softwares for that. Next, level 3 assessment is similar to division 2 part 5. Okay. Doing finite element analysis for that. Okay. So every part will have all the 3 type of assessment. First, you'll be starting with level 1. If you're able to qualify, very good. Your assessment is done. You don't have to go further. If you're not able to qualify, then you'll go to level 2. If you're able to qualify with level 2, very good. Otherwise, you'll go to level 3. Okay. If you're not able to qualify with any of the levels, then what you can do or what you will be doing? If you're not able to qualify with any of the levels, then what? So replacement definitely is an option, but it's a very costly option, right? So before doing replacement, you can see or think about re-rating. Re-rating means running that equipment for lower pressure or temperature. So if you are little bit able to tweak that operating parameters, okay, without influencing your actual process, it should not happen that your process still is getting deteriorated because of that. If that is not happening, little bit adjustment in the operating parameters, you may be able to qualify that. Okay. And you also know that operating pressure and design pressure and MAWP, both are, all the 3 are different, right? So your equipment actually may be having higher thickness. So MAWP is much higher. Okay. So you may re-rate that at a pressure which is closer to operation. Okay. And continue to use at the same operating pressure. Okay. So re-rating is the option which you'll be using if all the levels are exhausted. Okay. If re-rating is also not possible, then you're left with nothing. Definitely you can do the repairing if it can take care of that. So repairing is one option. If that is also not working, then replacement. So that is how this complete thing will flow. Most of the engineers, design engineers or inspection quality, they will be involved in 579 fitness for service. Okay. Because of the multiple projects which are coming up for re-rating or fitness for service. Okay. So if you are ready, definitely you will be able to take care of that job. If that job has already come, then you will not have time to learn that. Okay. All that is 14 different parts and different level assessment. Okay. It's tricky. It's not that simple. So you need definitely assistance in learning these. So we are there to help you. We are going to launch 579 course, and that will be a live course like what we are doing right now, with you people having coming online live. We'll be recording the sessions, we'll be sharing the recordings, we'll be doing Q&A sessions. Okay, so it will flow into that. What we are going to cover, we'll be covering starting from part 1 to part 14. Okay, theory and example. At least 2 or 3 examples will be taking for each and every type. Okay, covering level 1 and level 2. Will not be touching level 3 at this stage because that requires FEA skills, which is available with very few engineers. So we are not targeting that. Only design bureau. Okay, it will be virtual like this live session online. It may run to 24 to 30 hours, maybe more than that. Maybe running for 2 to 3 months, depending upon the classes when we are conducting. Mostly we'll be conducting on weekdays after office hours. E-learning also will be available for you because you need access. If you refer something one time, it's very common to forget that, right? We cannot remember most of the things. So recordings will be available. You'll be having study material. You'll be having test included in the platform. We'll be having Q&A session even after the course is complete. Okay. 3 months after that, we will be providing the support in terms of Q&A. We'll be having a WhatsApp community, which will be used for discussion. This batch will be starting from 2nd May. So we still have half of the March and April. We'll be starting from 2nd May. Okay. Now, a few important things about this is that, see, live session we don't conduct all the time. Okay. Now for fitness for service, this may be only session where we are going to conduct live. Once we conduct live, we'll record everything, edit that and convert into courses, which will be available later on as an e-learning. Okay. But live session, you're not going to have that if you miss this opportunity. Okay. Now that I'll show some numbers which will blow your mind. Okay. This we have already discussed. Over 40% of global oil and gas plants. If we talk about only oil and gas plants also, there are many other plants, right? So global oil and gas plants, 40% of them are now more than 25 years of age. Okay. They have seen their life. So now there will be shutdown planned, and many of them already this FFS is running. Okay. That they're already doing that fitness for service, and which inspection can be taken even prior to shutdown, for which you don't have to wait. That kind of data can be taken, and we can start even prior to shutdown. Some of the plants may be under shutdown and under the assessment. Now, the increase in number of the equipments or plants coming for fitness for service is increasing 15 to 20% per year. Okay. So you can see the increase, and that is the ASME 2022 report. Okay. It's a report from ASME. Okay. So I'm not taking from somewhere, but ASME 2022 report related to plants. Another study by DNV GL study, there is a report that if we adopt fitness for service, we can save $3 to $5 million in the equipment replacement. Okay, instead of replacing, if we do fitness for service, which may be possible for almost 70% of the equipments. Some of them may be seen their life. Okay? We cannot use them. We may try to re-rate or may try to repair, but just FFS may not be sufficient. For that, maybe the 30% of that. But 70% of the aging units, if we apply fitness for service, we can save $3 to $5 million per equipment. Remember, that's per equipment cost. Next, fitness for service. See, there are OSHA and PSM groups. Like OSHA is safety related, and process safety management group, PSM. So whenever they do compliance, so they have made it mandatory that whenever the repairs happens on the plant, they have to perform fitness for service. You cannot just repair and go ahead. Even if you are repairing, you have to perform fitness for service. It's a mandatory requirement now. Okay. So, and that results into almost 90% of the high risk equipment. When you're doing repair, it has to see fitness for service. Okay. There is no other way. So if someone is found non-compliant, if they are not having FFS report, they may be subjected to fine of $150,000, okay, for violation per equipment. Okay. So it will result into very huge cost compared to the cost of FFS. So nobody will try to avoid that, right? You will have to do it. In 2022, more than 50,000 FFS assessments were performed. Okay. So this many FFS has been performed, 50,000. Okay. In 2022 data. I don't have data after that, but 2022, there was a report published where this came from the softwares which people are using. Okay, so the report related to how many assessments were performed. So 50,000 plus. Okay. Now, for job related, like if we talk about what will be the impact on the job. So if you see the data which is LinkedIn engineering trends, there I found in 2024, the FFS skill, the need for FFS skill in the job role increased more than 54%. Okay, it's a huge rose. Okay, in 22 it was 30%. From 30% in 2 years it became 54%. Okay, so whatever job postings were there, which requiring FFS skill, the increase in the jobs which are requiring this skill rose by 54%. It's a very huge number. Okay, so definitely demand in terms of skill, in terms of in skill not only related to quality or inspection, but definitely designers, material engineer, okay, everyone. Okay, they have to be aware of this code. Now you may be noticing the uses of this code very high. Okay, when companies are creating a different department for that, which is working for fitness for service. Okay, so it has become now a must requirement. It is not good to know thing. It was good to know thing maybe 5 years back, but now it is must to have.
For in-depth training. And to learn more about these courses, register with the link in the description.